We're very excited for today's webinar, of course, because we're together. I think this is the first time that we're doing one like together in the room together. So it's going to be a lot of fun for us and hopefully for all of you watching at home or work, wherever you are. And we're going to be covering all things Wi-Fi design related. So we've got a bunch of theory to cover, and then we have some really great product news, and we have our amazing Mike with us. He's going to be showing you some live demos. Oh yeah, Mike's doing a nice little dance in the background. He's going to show you some really cool live demos of our Ekahau AI Pro Online. So before we get started, Stu, why don't you do a quick round of intros?
All right. So joining us this evening, we've got the ever so I guess technically minded, handsome Mr. Mike Prisker. We've also got Dale Tyler on the back end there, helping out with Q&A, and of course Justin as well. And then we've got myself, Wireless Stu or Sidekick Stu, and of course my partner in crime over here, Mr. Matt Starling.
Yeah, thank you so much, Stu. And actually, before we really kick off the webinar today, we have something to announce and launch. And if I take us back ever so slightly to Wi-Fi Day, there was something mentioned in the chat during Wi-Fi Day. And I think the thing that's so special about Ekahau webinars is the community, our Ekahau community and the chat. We have so many hundreds and thousands of you that join us, and you love talking amongst yourselves in the chat on the Ekahau webinar. And it's been requested a few times saying, oh, it's so good that we've got this community and we can have this conversation, but we would love to extend it outside of the webinars. So we looked at that and we thought, well, what could we do? So today we are actually launching a new Ekahau public Slack channel that you can join. So if you would like to join a public Ekahau Slack channel, all you need to do is scan that QR code. It's going to take you over to our Ekahau website, or you can just head to ekahau.com/Slack, fill out your details. And once you've done that, it's going to send some information over to Stu, and then Stu is going to have to go through that and process everybody joining the Slack channel. But the main reason we wanted to put it together is just so we can continue this amazing community engagement on outside of the webinars. There's going to be members of the Ekahau team there, as well as however many hundreds or thousands of you decide to join, and we can talk about all things Wi-Fi and Ekahau related. So if you want to join, please feel free to sign up. If you miss out on the QR code now, don't worry, we'll put it back up, or I'm sure that we will have someone from our marketing team drop the link in the chat. So looking forward to seeing you all in there. Oh, Mike, you've raised your hand. That's very official
Just,
on a...
just a question. Should we only discuss Ekahau? Can I like share some funny cats or something? Or it's
Mike,
not
if you
allowed?
want, if you want to share some funny cats with people, I'm sure they will be more than happy to see some of your
Okay.
funny cats.
So it's only me who allowed to share cats. All right. Yeah,
Well,
I'll keep that in mind.
people may want to share their funny cats back with you, Mike. Who knows? We're going to find out in the new Slack channel very soon.
Cool. All right.
Taking the conversation then back to the art of Wi-Fi design. And since we have so many of you gathered here today, I'm pretty sure we can say that you've probably already got an existing Wi-Fi network, or you manage an existing Wi-Fi network. So one of the questions you might be asking yourselves or thinking is, when is it time to do a redesign of my infrastructure? And sometimes you will know this, and sometimes your users will let you know this. But I think we've covered some of the most common ones here. Probably one that I think is the most common is that when you're getting an aging infrastructure, perhaps the model of access points that you've got, they're getting a bit old, they're moving into end of life or end of support, and you're due that Wi-Fi lifecycle upgrade. And that's probably the time when maybe most of you take to actually go and do a new design of your environment and upgrade to the latest and greatest model access points. Or maybe the performance of the Wi-Fi, since you put it in, it just isn't meeting what you want it to be from today. We know how important Wi-Fi is to everybody. We know that the demand on Wi-Fi is getting greater and greater and greater. Perhaps we didn't have that in mind when we first put it in, had it designed. So it's getting a little bit slow and we need to make things a little bit better. Sometimes our environments just change. If you're in an office, if you're in a warehouse, sometimes you move things around. Sometimes you need to have larger meeting spaces. Sometimes you take on extra parts of buildings. And that could be one of the reasons why you need to do a new design to meet the requirements for these new areas, or just simply because something has changed moving inventory levels around. Like we see people that have got racks that you can push around warehouses and stuff, or manufacturing plants, and you've just got to adapt and be mindful and make sure you can still provide that coverage in those areas that you need. We mentioned earlier that sometimes your requirements can just simply change. The way that you was putting in Wi-Fi 3, 4, 5, 6, 7 years ago, perhaps just to provide fairly robust Wi-Fi, but not super critical wireless first, and you wasn't having so many voice and wireless video calls over a Zoom, Team session, Google Meet, whatever it is that you use. So you need to make sure that now you've got enough access points to provide that capacity for those devices. And last thing that we put there on is you want to cut ties with those cables. We know it's expensive to run cable to all of your desktops, all of your different physical locations inside of your environment. It's a lot cheaper to put in wireless access points and then be able to provide connectivity for multiple devices rather than just to one device, save on switch ports, save on cabling, and it can just be a lot more efficient. Those are some of the reasons that you might be looking to redefine or redesign your wireless network. If I've missed any or this doesn't quite cover what you do for your environment, let us know in the chat. I'd love to see some of those things coming in there. When you might ask yourself, well, okay, I know I should be redesigning my Wi-Fi network, but how should I be doing it? And well, the answer is it's always on a case-by-case basis. There's never one size fits all when it comes to a Wi-Fi design or a Wi-Fi deployment. And you should always go through a set of questions with your stakeholder to really understand what is the requirements for this particular Wi-Fi network, because you might have even just having the exact same multi-story building and you've got maybe just two offices with pretty much identical layouts. What company A might want on floor 5 will be completely different for what company B wants on floor 4. So you should always sit down with a stakeholder, really understand is what is the main purpose of this new Wi-Fi network? Are you looking to achieve voice and video over wireless, wireless first office? Is it going to be fully redundant? Are you in a warehouse? Is it the scanners? Is it 24/7? Do you need to have complete redundancy in case something goes down? You've got enough nearby access points to cover that. And you need to understand what those requirements are. What are you looking to achieve from this Wi-Fi design that you're going to be doing? Then once you've had that conversation, you kind of move on to this next area around the technical requirements. And this is typically when you're going to define what access point manufacturer you're going to go with and particular antenna that you might need to use, because the stakeholder may have a vendor in mind that they have to go with, or they might actually just look to you for advice on which one you should choose that would be fit for purpose. So you would sit down, understand that, and then go through probably one of the most important, crucial parts when I think back to when I was doing lots of professional services, and you get the floor plans from the stakeholder and you say to them, okay, well, where do you want Wi-Fi? And they go, everywhere. Of course, everywhere is where I want Wi-Fi, right, Stu?
That's right.
Yeah. And then you go, okay, you want Wi-Fi everywhere. And then you sit down with them in the floor plan and you point out some of the locations. So it looks like you've got lots of stairwells around and you've got these plant areas and you've got this outdoor space and the toilet. So you want Wi-Fi in all of these places because you're going to have to put a Wi-Fi in each, an access point in each stairwell because it's, concrete or brick and it's really thick walls, so it's going to block the Wi-Fi from outside of there. So it's going to mean you're going to need X amount more. And in these plant areas where you got all this machinery, do people really go in there? Do you need to have Wi-Fi? And all of a sudden, sometimes the requirement areas start to get scaled back. But sometimes you may speak with the stakeholders and they say, no, Matt, I really want Wi-Fi everywhere. So if you go through the stairwells, up and down them, you need to stay connected on the phone. If you go into the plant areas, we need to be able to scan or communicate with members of staff. And the most important place we need Wi-Fi is in the bathrooms because that's where most emails get sent, apparently.
Well, don't look at me. Don't look at me. I'm not sending emails from there.
I'm using Slack only at those places. So
Okay. Okay, so Slack is from the in the bathrooms. They say you need to have good Wi-Fi in there because to use the new public Ekahau Slack channel. And then the last thing just to point out there is regulatory domains, because especially with 6 gigahertz now, like understanding what you can and can't do in terms of channels, transmit power in particular regions is really, really crucial. Then finally, the RF requirements. This way you're going to kind of define like what coverage minimum thresholds you're going to be looking to achieve, signal to noise ratio, and co-channel interference. And actually what I wanted to do today is kind of go over these RF requirements because yes, depending on who you are or what vendor you're working with, you may have a different set of thresholds that you might be working with, but as a general rule of thumb, this is typically what I would say a lot of people are designing towards to achieve this minimum threshold for these different criteria. So I wanted to explain a little bit why you see these criteria and this thresholds that we're typically going for. So we've got the 3 frequency bands, 2.4, 5, 6 gigahertz. Then when you look at the primary coverage, we can see that we're looking to achieve a signal strength of -67, and then on secondary signal strength, we're looking to achieve -67 as well. And then we've got a signal to noise ratio of 25 dBs, and then a maximum co-channel interference, ideally none on 5 and 6 gigahertz, but realistically on 2.4, it's very likely that you're going to have potentially at least 2 or 3 devices sharing the same channel just due to the sheer not much frequency space we have to use. So then let's break it down. Why do we want to achieve for our primary coverage to be within this -67 dBm threshold for our coverage? So if we have a client device that's within this green zone of signal strength, let's say, typically this means that your client device is going to have a good signal strength, they're going to be able to have good data rates, they're going to be able to do the application over the wireless network that they were looking to do, whether that be a voice call, a video call, send their traffic, they're probably going to have a good experience on the Wi-Fi. Then we have this kind of like gray zone. So anything that's in between -67 dBm to -85 dBm, we don't really want to be here for a couple of reasons. The first one being if you're a client device and your signal strength is below -67 and it drops down to, let's say, -70, -75, there's a good chance that whatever you was trying to achieve on the Wi-Fi, it might work or it just might not be that great. You could be on a voice or a video call, it might start to get a little bit choppy. If you're trying to send or download a large file, it might take you a lot longer to do because you can't achieve those higher data rates. And also from a client and access point perspective, when you have more than one device on the same channel that can hear each other at this signal here at -85 dBm or greater, they take it in turns to access the medium. So you don't have a great signal strength and you don't get to access the medium to yourself if you're sharing it with another access point. So that's kind of why we want to achieve that from a primary coverage perspective, and why we say from a secondary coverage perspective, we look to achieve access points being able to hear each other at that -67 dBm or greater is for two reasons. Mainly, it's because you want your client devices to have options when they're going to go through that roaming algorithm. So access points that can hear each other, they can build their neighbor reports and inform client devices of other access points to go and associate to that can really speed up the roaming from the client's perspective. But also, with Wi-Fi being mission critical, if you have an access point failure for whatever reason, the AP becomes faulty, a rat chews for a cable, a switch port goes down, a switch goes down, whatever, you want to have enough backup coverage from a nearby access point to still provide connectivity for your client devices so that you don't have an impact on productivity and production for your environment. So that's what coverage is about and why you would typically see those thresholds. So signal to noise ratio, what is that? Well, signal to noise ratio is basically the difference between the received signal strength that a client device gets from an access point versus this background noise that is always there. And now the background noise is typically operating at around -95 dBm. So if I have a signal strength or from my access point at -50 and my background noise is at -95, that would give me a SNR value of 45 dBs. So if I was to have a -60, it would be 30 dBs. And the minimum kind of SNR that you want to be achieving typically is around 25 dBs of SNR. And the reason for that is because when you've got a minimum of 25 dBs signal to noise ratio, that typically means you've got a fairly good signal strength compared to the noise in your for your signal. And that therefore means that your device should be able to do faster data rates, higher MCS, and have a better experience on the Wi-Fi. When the SNR drops down lower and lower and lower and lower, it means you're not going to be able to do more complex modulations. That means slower data rates and not able to potentially have really clean connection to your access point. And if you're trying to do time sensitive applications, voice or video calls, then you could run into some issues there. So that's why we want to achieve ideally at minus 67 for primary and secondary coverage, and 25 dBs of SNR. Well, what are some of the things that can affect signal to noise ratio or the quality of our signal? And it can actually really come down to how we placed our access points in the environment and the physical obstructions that there may or may not be around. I've seen, I don't know how many times in my experience, someone does an amazing design, they provide great access point location details to the install team, and then that install team takes it and they go and physically install it in the environment, and they just try and put the AP right on that X marks the spot. And they don't really take into consideration what is going on in the ceilings. And if I just maybe show you all this kind of example here from this access point, is probably not the best place for an AP to be living around all of this kind of metal ducting and HVAC system, especially so close to the AP. It's going to cause so much like reflections. It can cause the quality of the signal to deteriorate, retries, and it's just going to be a poor experience from installing our APs like that. So we would much rather suspend it down away from any of those kind of materials or obstacles to bring it kind of clear line of sight to our client devices. So please make sure that you don't install your access points like this in your spaces, and try and avoid this kind of environment. Just a simple drop pole, get it away from that. It makes it so much better. So then when it comes to the co-channel interference and interference in your environment, the reason why we want to ideally minimize that to on 5 and 6 gigahertz, trying to have none. In some cases, you might have 1, 2, 3 co-channel interference. That wouldn't be the end of the world. However, on 2.4 gigahertz, it's very likely in some of your environments, you're going to have 6, 7, 8, 9, 10, 10 plus, 20 plus, sometimes sharing the same channel with some of the things that goes on in 2.4 gigahertz, people bonding channels together, the amount of non-Wi-Fi devices that operate there, and even lots of non-Wi-Fi devices that actually creep into 5 gigahertz, like wireless video cameras, passive infrared devices. And why we want to minimize the amount of channel interference as possible is because Wi-Fi is a very polite protocol. You might have heard that many times before in any kind of Wi-Fi presentation, but that's just how Wi-Fi is. It's a listen before you talk medium. Your devices, your access point or your client devices, it's going to check to make sure no one else is trying to occupy the same channel that you want to transmit on. If it's clear, then great, I will try and transmit my data to the destination. And there's a couple of ways that our client devices or access points will check to see if the medium is free. And you can think of it in like a physical way and a virtual way. So the physical carrier sense is basically a device is going to listen on the channel. Can I detect if there is any energy happening on this channel? So think of this as like kind of like layer 1 energy kind of detect. Do I understand if this is Wi-Fi or not? So it does this preamble detect or signal detect, and basically this is where you could have a microwave oven operating on 2.4 gigahertz. The device listens and goes, oh, I hear something really loud or whatever. I don't know what it is. I don't know how long I should not be transmitting for. I don't know how long I need to wait for. I can try and transmit. And in some situations, your access points may just completely back off and not try and transmit at all. Or sometimes they might just think, oh, I don't know when I can transmit, so I'm just going to try anyway and try and shout over it and hope that my transmission gets there. And sometimes it might, sometimes it doesn't. If it doesn't get that acknowledgement, then it's going to retry and it's not going to be great for us. And then, however, on this right-hand side, our virtual carrier sense, this is when we can detect that there is other Wi-Fi devices on the same channel. So if it's access points to access points or client devices to client devices. So in this example here, we can see that all in this channel 36 threshold, and we've got the client device over here that's transmitting, and it basically informs everybody on the channel that, hey Stu, hey Justin, hey Dale, hey Mike, I'm going to be talking for the next 40 minutes straight is probably what you're thinking. But the device basically informs everybody, say, hey, I'm going to be talking for this period of time. Everyone goes, okay, Matt, I know how long you're going to be talking for. I can just pause for a bit, wait for you to be finished, and then I will continue to then try and access the medium. So minimizing the amount of non-Wi-Fi interference plus minimizing the amount of co-channel interference you have in the environment is just going to improve the performance of your Wi-Fi network.
And that's a perfect example of me listening before talking.
That Wi-Fi working in such cohesion, no co-channel interference here. However, if you do have a wireless network that does have lots of channel interference, when you do a survey of Ekahau and the Psychic 2, we test everything from the client's perspective, and then we have an amazing algorithm that can actually automatically come up with a new channel plan for you. And this was a warehouse that had hundreds of access points that was really having a poor experience because of the amount of channel interference it's experiencing. We was able to optimize it from doing a new channel plan and then deploying that and really improving the performance of the network. So it does make a huge difference. So the product news that we're going to be talking about today, which we'll be coming to shortly, is actually for our Ekahau AI Pro Online with the new predictive design capabilities that Mike is going to take you through shortly. But when it comes to Ekahau and with Wi-Fi design, we have a choice. I really hope people are going to get this reference in here. Otherwise, it was a complete fail by me, but guess we'll see. But yeah, we have a choice now when it comes to doing Wi-Fi designs. And the way I like to think of this is, especially with Ekahau AI Pro Online, is the one option that we have is if you've been able to do a site survey of your environment and collect real measured survey data with the Psychic 2, you can now import that data to Ekahau AI Pro Online, and without drawing any walls or any obstacles, we understand how RF propagates around your environment, and then you can do a redesign of your environment or design a completely brand new environment, like simulating upgrading to 6 gigahertz, even if you only have 2.4 and 5 gigahertz access points. And this is an extremely fast, great way to do it, and you don't have to draw any kind of walls or obstacles. Then, however, you may be in a situation where you can't access the site yet, you can't go and do a survey. We're in Dubai, for example, and when we look around outside, you can just see there's construction everywhere. They're very fast at building lots of new offices or hotels or apartments or whatever. And sometimes you just need to understand how many access points you may need for this new building that's being built. I can't go and do a survey yet because it's not physically constructed, but I need to understand how many APs I might need. So I want to do this traditional kind of method of predictive modeling, import a floor plan, set a scale, place my simulated access points, and get an understanding of how many APs I might need. It's still super critical and important when the site is ready that you go and survey to really understand the materials, the attenuation, where you can and can't physically mount access points, etc., etc. But you have got an option now to do it either way with AI Pro Online. So why the AI Pro Online is so good with the measured survey data is because we really build a kind of like a digital model of your environment and understand how RF propagates using machine learning and AI from the measured survey data from the Psychic 2, which means that you can then plan and account for changes without having to draw any walls or any obstacles. So it's super fast. And the other thing is it's super accurate as well. Then if you need to do the traditional based modeling, then you have that option available. We have great automation tools for you in the new AI Pro Online predictive modeling, such as automatically detecting any walls for any types of floor plans. So not just a CAD file or PDF, but even PNGs and JPEGs. So it's going to really save you time. We've been able to come up with a great Wi-Fi design as well. And the other thing I don't want to steal too much thunder from Mike, but one thing I do want to hit on is that RF modeling really, you want it to be as accurate as possible. So getting all of your attenuation values right, of course, but the other thing when it comes to the heat maps, typically what you might have expected us to use is just free space path loss for the formula for the heat maps and then subtract the attenuation values for our materials. But actually AI Pro Online also includes reflections and diffractions for your heat maps. So that means that they're as accurate as they can possibly be for what you simulate in the software to match what is actually going to be there in real life. So when I think about the workflow now, for you and our amazing customers and users of Ekahau, the fact that you can go and survey your environment with the Psychic 2 and plug it into your mobile device has never been easier and more mobile friendly to just walk around and collect survey data. Once you've got that survey data, you can use Ekahau Optimizer to automatically understand how your network is performing and then give you requirements based on your specific network and what your outcomes you want for that network to be, and make radio level configuration changes to improve the performance of your network. And then once you're finished doing those optimizations and you're ready to upgrade to a new model access point or redesign your infrastructure, you can use AI Pro Online to easily and very fast come up with a new design, which I just think is just such an awesome workflow for now when it comes to Wi-Fi. Would you agree?
Oh, absolutely.
Okay, good. Glad Stu's on board. But Wi-Fi surveys, they are so important, whether you're going to take whatever method that you want to take, if it's the measured survey data or going to do the predictive modeling traditional method, you still need to go and do a site survey to understand your environment. It's so crucial to understand how many interferers you might have, what channels you can use, your attenuation of your materials on site, and also just doing a visual inspect of where you can come at access points, cable runs, that kind of stuff. So first unofficial tip is have fun. We really believe we're the fun brand. We give you the fun tools that you can go and do site surveys with to make your life easy. I don't see anyone across my time not having a big smile on their face when doing a Wi-Fi survey, doing lots of demos to people here at the conference. And when you show them the tools and they start doing a survey, they just have a huge smile on their face. Or when I see people around Stu getting demos from Stu, they're pretty much crying from happiness the whole entire time because they're having such fun. So a few quick tips when it comes to doing a site survey. You need to make sure that you scale your floor plan accurately. Now, there's a few methods that you can use to do this. Ideally, you want to try and use the longest distance as possible. If you go on site and measure with a laser measure, sometimes you have floor plans that have a scale on them, but you always want to kind of verify and validate that. Sometimes now you can even use your iOS devices or even probably Android devices have some sort of measure scaling application that you can use. But it is really important. Everything is distance related when it comes to Wi-Fi. So make sure you get that accurate. It is really important that you use Ekahau Sidekick or Sidekick 2 because it is the only Wi-Fi measurement device on the market that brings you Wi-Fi radios as well as a spectrum analyzer integrated to it as well, which is super important to understand how not only your access points are behaving, but also to detect any kind of interference on site with that spectrum analyzer. If you don't use a spectrum analyzer, you're quite literally missing half the picture when doing a site survey. And all of our Sidekick 2s, they're super accurate. They're all calibrated before they leave the factory and they're all in within extreme tolerance of each other. So they are consistent. So if Stu does a survey, I do a survey, Mike, Justin, we do a survey, all of the data is going to be the same and consistent. Next, it is really important that we survey accurately. We need to get good data in to get good data out. So if you're using a survey method where you're telling the application where you're moving around and you are not putting it in accurately, then it's not going to understand that you didn't put it in accurately. So then the data that you get out will not be accurate as well. So I always give a recommendation to make sure you can find some really physical reference points, use columns, lift shafts, actual doors, things like that that you know are really there rather than kind of furniture to give you that kind of reference before you start moving around. And then make sure when you're doing your survey is that you walk on both sides of what you care about and go into all of the rooms that are crucial to you. Don't just walk hallways, make sure you go into as many rooms as possible, go on either sides of the walls. That's how you're gonna be able to work out these values. And especially when you're using Ekahau AI Pro Online, it's really crucial that we do that. And then use the right survey method for you and your environment. So let's have a look at these survey methods. So first of all, stop and go, probably the most traditional survey method out there, where you have a floor plan inside of the survey application, and then you'll go to a particular point on that map. You basically go there, you tap, you wait for a period of time. It's by default 5 seconds. Once that time's passed, it's collected data in that position, and then you move to the next location, tap, wait, and it's gonna then collect data as well for that location. However, that little bit in between though, there's no data being collected. So I wouldn't recommend to you personally as your go-to method to be a stop and go survey because you're effectively just missing out on quite a lot of data. Unless you're in a really tricky, hazardous environment, that's when I would maybe suggest using a stop and go so you can be super aware of your surroundings. But I think realistically, I would go for a continuous or autopilot or just go survey. Now, continuous mode is effectively you are going to be constantly tapping on the map or clicking as you're moving around. So basically when you start your survey, you would tap in the location that you are, you move down the hallway, and then you're about to turn into a room, you would then tap on the map again, go into the room, tap as you go to a corner, tap as you get to the next corner, tap as you get to the next corner, and then so on and so forth. And you just keep constantly telling the application where you are as you move around. Again, this has been a very traditional survey method, been around for, gosh, how long?
Oh, at least for the last 20 years, for sure. Right?
Yeah.
So old school.
Old school, very old school. And then, but nothing wrong with using it. I still use continuous sometimes. Good old, sometimes I just like to use it. But one of my favorite survey methods for sure is autopilot. So autopilot is great because basically what you can do when you've got the floor plan is you just give a couple of reference points. So a reference point for where you are currently, you then move for a distance, and then you give another reference for where you are. And then what will happen is the survey path will just automatically update as you move around. So this does require you to have an iOS device, and it does work better with devices that support LiDAR because it's using the Apple augmented reality kit, so camera, gyroscope, etc., etc. It's really great. You can move around a lot quicker. You can open doors a lot easier. You can do it on your phone, on your iPad, and it's just a great method that we've had around for a while. And then I would say Just Go is still the wow factor. We did some demos today for people doing the Just Go survey, and the crowd that it brought around when you start to use it, because effectively you don't even need to have a floor plan. You don't need to tell the map where you are. You don't have to give it a scale. If you've got an iOS device that's got the LiDAR scanner, so basically a pro version of the Apple device, you can just connect it to your Sidekick or Sidekick 2, hit go, and then start surveying. So it's a great option if you don't get up-to-date floor plans, if you don't get any floor plans, or you just need someone to just quickly collect some survey data for you to then take a look at and analyze, then it's an awesome method. We've got a little clip for you demo on the next slide, but before I jump to that, the last one I want to give a shout out to is the GPS survey method. And I know we spoke about this quite recently. Some of the customers you've been speaking to that do, let's say for like mining, for example, when you've got even if you want to do an outdoor survey, you don't have to do a GPS survey to do an outdoor survey of a city, for example, because if you import a floor plan of the Apple Maps or whatever, Google Maps, whatever map system you use, you will see that there's reference points that you could do a continuous survey or an autopilot survey and tap as you walk around the outside. But however, if you need to do a survey outdoors where maybe you haven't got many reference points, like a mining site, for example, shipyards, anything like that, but you haven't got any physical reference points that you can use, leveraging GPS to be able to track your survey path has been a game changer for some of our customers, haven't it?
Absolutely. And also one of the things is that we talked about this before is sometimes maps aren't always up to date, right?
Mm-hmm.
And one of the solutions that I tried recently with a customer was a drone image. So get the drone up high enough, grab it, put it into Ekahau Survey, and you just need to mark the 3 access points, and you're off to the races. You are surveying GPS in style, like with real time, almost near real time imaging.
Yeah, perfect. Okay, cool. So a very quick example of the Just Go survey. So Stu, I believe this was you quite recently at a hotel. You're using your iPad, and just talk us through what's happening here.
Oh yeah, so this was really cool because the issue here was that we knew there was something going on, but we didn't have a floor plan right away. And I was like, I'm going to try this new tool. Let's go. And so all I did was put up the Just Go. It was a click of a button. I was instantaneous, and I'm scanning along the side of the walls. Now what I'm doing here is I just needed to see what was going along the conference area, and you can see on the right is where it automatically mapped out the rooms. I walked in, the walls were created. I didn't have to do anything else. And it was super it was a huge time saver because I was diagnosing, optimizing it right away just to figure out like what our troubles were.
Mm-hmm. Yeah, so handy, so helpful. If you don't get a floor plan, you just want to know what's going on. So helpful. And I even just went onto LinkedIn earlier and I saw some people posting about some of the Just Go surveys that they've done recently. And it's really cool to see people using the wild. So if you've done Just Go surveys and you want to share it with us, feel free to post it, tag it, or send it to us. I love seeing all of your examples of using it. All right, well, that's the theory covered. So I'm going to pass it over to Mr. Mike to take us through Ekahau AI Pro Online. So, Mike, over to you.
All right. Yeah. Thank you for such a long introduction. Now let me just try to show it in a real, because I guess it's gonna be more fun just to take a look on the real show, right? But hey, guys, thank you very much for such beautiful slides. Okay, here we go. I guess now you should be able to see my screen. Yep, that's the AI Pro Online. Fresh, and here it goes. So this is the project that we did a couple of weeks ago. As Matt said, we just like took our phones, took this beautiful piece of hardware, just walk around the place and just collected some data. And after that, we just uploaded the whole project to the cloud. Cloud made it fancy AI ML magic. And here we are. This is the access points, the actual access points which were placed at the place, right? But here's the thing: we don't need to draw walls. You can just like start playing around with your access points. You can just, if you of course want, you can just, I don't know, take this access point and put it here and check the results. Maybe it will work. If you like don't want to do that, of course, you can put it back with a fancy animation, of course. Or if you just want to switch those old school APs, or maybe they just, I don't know, colored with the wrong color. They're white and you would like to go with something black. That's up to you, right? Just like go and switch to something fancy. I don't know, like Cisco. What do you guys prefer? Let's go with the HP. Okay, this one probably will work. Yeah, and it's simple as that. You can just like try different models, put them here and there, and check how your network will perform. For example, if you're using some really old shit, just try with the Wi-Fi 6E or 7. Why not? So as simple as that. By the way, if you just want to have some fun, you can even try to take all your APs, right, and just like move them and watch on this fancy cool animation. As you can see while I'm dragging those APs, you can actually see that there are kind of walls there, right? There are no literally walls, but we know what's the radio propagation of those obstacles that are all around the premise. So as simple as that. Just do the survey, walk around, I don't know, buy an ice cream, eat ice cream, do a survey, go back to your office, buy another ice cream or beer, and just start playing around with dots. I don't know, as simple as that. And if you just okay with your original design, once again, you can just like return those things back. Or here is another way: you can just select all and just delete them, and you can start placing new access points right from here. So you don't need to draw walls. Once again, I can say that 100 times. I will say it every seminar, every webinar. You don't need to draw walls anymore. Just start playing around. And by the way, Assisted Planner can help you with that. If you're too lazy, to do it by your own, or you have no time, or just like for some reason, just use this predefined dots here and there, or just place all your access points. If you don't like this design, of course, you can go back to your original network. Just delete all these and restore all your existed devices.
Hey, Mike,
Something like that.
quick question
Sure.
about the assisted planner. Is it specific for the AP model that I'm using?
Actually, no. That's the beauty of the assisted planner. It knows what kind of access point you'll select, and it will know the properties of that access point and the antenna pattern. So based on those data, it will optimize your network coverage. It will place the right amount of access points. So it's not about just like some, I don't know, some gimmick generic model. No one likes them for some reason. So that's the thing. It will work with your specific APs. It will tune your network for that specific AP that you will select.
So basically what Mike is saying is that depending on which model access point and vendor that you decide to go with, the assisted planner will give you different recommendations based on the criteria of that access point, which I think is pretty cool.
Yeah, I agree. That's the thing. Yeah. So that was the short demo, by the way. This mode is actually available. So you guys always welcome to jump on our website, ekahau.cloud, if you have a license, of course. Just start playing around and enjoy the beauty of the ML and AI. Yeah, so I guess that's it for now. First part done. Let's move on.
Yeah, over to you to do the designing in AI Pro Online on the traditional predictive modeling, Mike. We'll jump back to the slides after you've done the next demo.
Okay, yeah, I thought that we'd have more slides, but if you guys eager to see more, sure, I'm here to help you. So
We're dying to see more, Mike. We can't wait.
Of course. All right. So as we already discussed, sometimes you just can't get into the place to do the proper survey, right? Just imagine the case that the building that you need to do the network is just did not exist yet. What are you gonna do? Probably you won't, just do the survey, right? You still need some kind of floor plans. You need to upload the floor plans, probably draw some walls. I'm saying probably. Let's just highlight this piece and start it from there. But even if it sounds kind of a hard, or for some people could even sound scary, it's pretty simple. So that's what we did in Ekahau. We just made it super simple, really, really simple. You know what? Like some people, and it's not some people, it's our marketing, right? They saying that doing surveys is as easy as just walking with a dog, right? Right, Matt? Yeah, but then someone said that even a dog can do the survey. So that's how simple this thing. And you know what? We thought that, hey, if making surveys, doing surveys, even dog can do that. So why not? Why not to improve this thing? And we got that, hey, you know what? Even a horse can do designs, right? So, hey, how you doing? Are you doing good? Yeah, and horse will do the design for you guys, but I'll be here to help. Is it fine? Is it all help? Sure. All right. So yeah, the horse is here to demonstrate how simple is that. Hope you guys are okay. So okay, I will start. Not me. I'm sorry. It's the horse. Like if you will see this, and by the way, this is not my screen. That's a horse laptop. So if you will see something like weird, that's not my laptop. Sorry for that.
We
All
don't
right.
see your
I'm just
we don't
sharing.
see your screen yet, Mike.
Yeah. I'm just press the button.
You're
That's
just
not
horsing
my
around,
screen.
right?
Yeah, there you go. Stu got you there, horsing around.
All right, yeah. So that's the new look of the Ekahau Cloud web page, but let's start from the scratch. New project. Pretty simple so far, right? But let's move on. Yeah, I will select the from scratch. I don't want to mess with the name. I'm fine with the regulatory domain. I'll just like press continue. And right from here, I need to upload some floor plans. Sure, why not? Super simple. Here, Mr. Horse will cut some corners by just selecting the distance between walls and assigning scale to 1 meter. All right, here. And you know what? Let's add one more floor. Are you fine? Sure, yeah, it's fine. So here goes another floor. Yeah, the name is okay. You know what? Since those floors actually are from the same building, we can easily form building, right? Now we got the building with the fancy roof. Probably that's not the real roof, but hey, I guess you got the point. So we can, by the way, we can create as many buildings as you want inside one single project file. Okay, I will do the same. Not me, of course. Of course, I will never do that. I will always use proper measuring. 1 meter scale. All right, we're doing good. We're doing good. And this is the new look how you can actually align your floors. You can just like press the fancy align button here, but let me just demonstrate how you can do it manually, just in case. So what you need to do, you need to grab this fancy tool, look for same places around 2 floor plans. I already know the place. I really like this dot here. I just need to move it on the same dot. So previously in AI Pro Classic, you used to place like a 3 or 4 reference points. So that was kind of a weird. But here, just find one reference point, put one reference point over each other, put this fancy anchor tool, and just start messing around. I'm just kidding. You just need to turn it slightly. Yeah, done. So how much it took? 5 seconds? Yeah, 5 seconds. Yeah, so you just aligned your floor plan. Hit the finish button. I think we're fine with importing floor plans. I'll just hit finish. So this is the floor plan, right? Just like a single floor plan. Here's another floor plan. What we should do next? What Horse can do in this case? Horse can start playing around manually, like drawing walls, placing access points. But here's the problem. Horse don't have fingers to do all those fancy things. Horse needs something simple. And actually, I also need something simple. So what I will do, just a couple of simple steps. I'll go to the wall tool, press the wall detection. Bam, we just detected all those walls, not just walls, right? I need to stop calling them walls because those things are actually materials, right? We have outer walls, we have doors here and there, and like some other walls that are inside the building. So now we can detect those things from any floor plan. Actually, what we even tried, we just tried to draw floor plan just with a hand. We did some really shitty floor plan. Just tried to upload, and like our algorithms were super easy to crack that kind of a task. So our algorithms can detect all different materials inside your floor plan. So yeah, we're done with the floor plan. Now we need to add some area. I guess I don't need to draw area because I just can press this auto area detection thingy. Bounce, here it goes, right? If I want, I can, of course, tune the Wi-Fi requirements, even play around with the colors. How cool is that? Or, let's just move on. I can just go to the device to start playing access points manually. But I still can place access points with the help of our beautiful assisted planner. By the way, here's a small teaser for you guys. You know what I'm talking about, right? Hey, let's just once again select something fancier than just the generic. Okay, what we have here? Cisco. Never heard about this company before. What we have here? Oh, this one, my favorite one, always. Okay, I just need to press, not me, once again. The horse will press, place. Oh, and here we go. We got, I just want to say that's the best design that I ever made. And it was super simple, right? With 3 clicks, detect walls, detect areas, and place access points. And it's done. As simple as that. I can just of course, if I want, or if Force wants, is it okay if I just tune your design just a little bit? All right, yeah, I can do so. You can just start playing around, just moving them. So if you just want to do so, of course, you can add more access points just by clicking here and there. As you can see, it's super fast, super natural, and you will see those cool fancy animations like live. I really like this stuff. Yeah. Even if I'll drag those APs, I will see how heat map is changing, right? That's super cool. Actually, what I did, I just sometimes I'm just turning the Ekahau AI Pro Online full screen and just leaving the screen on, and it works like a really, really good, like a lamp. This like a lava lamp, I guess that's how they call it, with this fancy animation. So yeah, that's the thing, right? Super simple, super easy. And even Horse can do that. If I can do that, Horse can do that. Probably even my dog can do that, because currently my dog is doing some surveys. I just want to earn some cash. Why not? Please don't judge me. But I'm still paying taxes on that. All right. Yeah, that was it. That's it, folks.
Oh, very,
Wow.
very good demo, Mike. Thank you so much.
Straight from the horse's mouth.
Yeah. All right. Thank you, Mr. Horse. See you soon.
Okay, we have a couple of last slides just to finish on the webinar today, and really wanted to hit home a couple of the best practices when it comes to Wi-Fi design. So we mentioned it earlier, but it's super important that you define the requirements with the stakeholder, that you really know what they're looking to achieve from the outcome performance of the Wi-Fi network, and then what you're going to deliver to achieve that. Understanding your environment, going to site, making sure you know what is physically there, the attenuation of your walls, your channels, your interferers, what APs you when you want to place your APs, can you place them there without being surrounded by all of that air conditioning, ducting, metal piping that we saw earlier? It can play a big part on impacting the performance of your Wi-Fi network. So going to site, physical inspection, RF inspection, understanding your neighbors, your interferers. You might have some non-Wi-Fi devices in there that you actually just physically can't remove, so you've got to avoid those channels from your plan. You can detect all of them with doing a quick survey with the Sidekick. Then when it comes to doing your design, the main thing is a rule I think is such a good one when it comes to Wi-Fi is that you really want to cover what you want whilst not covering what you don't want. So making sure you place your access points in positions where it's going to be providing connectivity for your client devices whilst not spreading it into places where you don't need them. So really thinking about your placement of your access points and where your client devices are actually going to be and using the Wi-Fi network. I give you a really fine example of this is that not so great placement for an access point in a scenario where we are right now in a hotel, in hotels, for example, like we're in the hotel room, this is where we're going to be using the Wi-Fi. It's not so great to place the Wi-Fi in the hallway where it's past the bathroom, past however many doors, and the signal could be quite weak by the time it gets to us. Then finally, I would say that this number 5 really does and is the kind of like that missing piece of the puzzle. You could have done an amazing Wi-Fi design, done a great survey, you're super happy with it, you give it to the install team, they follow your instructions, they install your access points perfectly. However, if you don't configure your Wi-Fi networks appropriately, or even to match what you've done in your design, the perception of the Wi-Fi might be that it's underperforming or it's not that great. So I wanted to kind of nearly wrap up this webinar, end it on some tips when it comes around the Wi-Fi configuration best practices. When you do a design in Ekahau, you're going to be typically using a transmit power, probably if you're using the defaults on 5 and 6 gigahertz, it's going to be 14 dBm. And yes, some of your access points might have antennas that have passive gain, so it could be up or down plus minus few dBs. However, what I see so much is when people then go and actually configure their access points on their radio profiles, is they will just leave things on default. So that means that there'll be no kind of guardrails or restrictions on the transmit power that your radios could use. So sometimes it can be anything as low as 1 dBm all the way up to like 20, 25 dBm. And why that can be a problem is because if you've come up with a great design and all your access points are either using 11, 14 or 17 dBm, and then your actual real access points when they're deployed, they're using a vast range of either 3, 5, 15, 18, 21, whatever, then how your actual Wi-Fi deployment isn't going to match your design. So it's much better to make sure that your deployment transmit power ranges match what you've gone in with your design that you know is going to work. When it comes to data rates, again, like this is just a kind of like guide and recommendation because it's not always one size fits all and it is always on a case by case basis, because our recommendation that we'll make to you 9 times out of 10 that you should use for your minimum basic rates for your SSIDs, either 12 megs or 24 megabits per second. However, if you have got a warehouse where you've got to support 2.4 gigahertz and really old client devices, if you disable everything below 12, that could mean that potentially some of those older client devices may not be able to connect because they are still using 802.11b rates. And I hope there's not too many of them out there, but I know from speaking to so many of you that you still have to support these devices sometimes. But if that's the case, do that on a specific SSID, do that for those devices, but for all your other devices that can use those higher data rates and are not that old, 12 or 24 megs is kind of like a good sweet spot there because it will really help reduce with that management overhead. Because remember, all of your management frames and control frames, they get sent out at whatever the minimum basic rate is configured. Channel whips, now mileage may vary here, and that's because it's not one size fits all depending on where you are in the world. But I would say on 2.4 and 5 gigahertz, I'm very comfortable in making this recommendation to all of you lovely people in the webinar today. Just go 20 megahertz wide 9 times out of 10. Yes, sometimes in your space you might be able to do 40 megahertz wide or 80 megahertz wide, but 5 gigahertz is getting congested. We know there's lots of devices out there. I would stick with 20 megahertz wide. You can get great data rates with 20 megahertz wide channels, and you want to minimize the amount of channel interference. 6 gigahertz, depending on where you are, you may be able to get away with using 80 megahertz wide channels, or if you're in Middle East, like we're in Dubai right now, they get 500 megahertz on 6 gigahertz. I get in the UK 500 megahertz on 6 gigahertz. What do you get in Canada?
Oh, we got it all.
So
We
yeah,
got it all.
Stu's got it all.
We got it all.
Stu gets it all in Canada. So Stu, he could probably go with 80 megahertz wide channels in Canada and have no issues with channel interference at all. However, me over in Europe and in the UK, we would probably go with 20 or 40. It really depends on how many access points we've got. Then points 5 and 6, when it comes to roaming, you really want to make roaming as fast as possible. So sometimes I see people configure their Wi-Fi networks that when a device roams between an access point, they actually have to pick up a new IP address. So what we're saying here about this layer 2 roaming only is we want to keep the same IP address as we're moving around access points in one building. So not having to go and request an IP address from a DHCP server. I saw an example on one of the booths earlier this week, actually. There was monitoring DHCP times for client devices, and sometimes a DHCP server was taking up to 9 seconds to respond with an IP address. And if you can imagine going between AP to AP and taking up to 9 seconds each time to get a new IP address, from the client's perspective, that's going to be a really bad experience. Then when it comes to the configuration for some of the roaming amendments, I would always recommend enabling 802.11k, which is neighbor reports. I don't see any reason why we wouldn't have this on. Basically, it just means your access points that can hear each other, they can actually form a table and then inform your client devices with that list of what their neighbors are using in terms of the channels. So it can speed up scanning times to go and find those access points to go and associate to. If you're using Enterprise or 802.1x for any of your SSIDs, I would highly recommend that you have 802.11r enabled, because this basically means that your devices won't have to do a full radius authentication each time they roam between access points. But a little asterisk here is you want to make sure that your client devices support 802.11r, because not every device does, unfortunately. So do test it in your own environment, but I would recommend having it on. And then the one that gets, I think, people on the soapbox discussion is 802.11v, because generally it can work really well, but sometimes it can be a reason why you have a bit of intermittent issues in your Wi-Fi network. And the reason for that is because it's always the client's decision on which access point radio to associate to, which frequency band, if you give it the choice, and when to go and roam and associate to another access point. Each device has its own different roaming algorithm, but what 802.11b does at a high level, effectively it tries to take that power back from the client device to the infrastructure. So the infrastructure goes, oh, Mr. Client Device, seems like you've got a bit of a bad signal there. You might benefit from going to associate to my good friend Stu over here, who's got a much better signal for you. So I send this disassociation imminent frame to the client device, and it keeps getting deauthenticated to hopefully go and roam to Stu. But the client device is like, whoa, Matt, I'm happy with my signal strength. I don't like being told what to do. I want to make the decision on when to go and roam to another access point. So do test it with your client devices in your real world environments and see from there. If you've enjoyed today's webinar, again, this is just a small glimpse into some of the theory around when it comes to Wi-Fi design. We've got some fantastic instructor-led training courses for you in terms of being able to be delivered virtually or in person, and to meet your time zone needs and your language needs. We have the best of the best when it comes to instructors, and they speak such a different variety amount of languages, and we cover all time zones. So wherever you are, you can do it virtually in your time zone and probably in your language as well. ECSE Design, such a fantastic course to teach you all the fundamentals about Wi-Fi and then how to implement them. And we have some other great options for you there. And if you can't take a 4-day instructor-led training course, we have the self-paced video-on-demand training for you as well, that you can go and watch in your own leisure and at your own pace. I would highly recommend them, unless you've had enough of listening to my voice, because you would probably find me on those videos. So hopefully you don't mind that too much. If you missed it earlier, we announced that we're going to have a new Ekahau public Slack channel. So you can just go to ekahau.com/Slack. We love you. We know you love everybody else in this wireless community that joins the Ekahau webinars and sometimes want to continue this conversation on somewhere. That's the exact reason why we have put this together for you. There's going to be lots of the amazing Ekahau team there. You'll be able to speak to our product team. You might have to speak to some of us in marketing, but we'll have other people there for you as well as all of you in the community joining on the webinar today, and as we continue to promote and announce the Slack channel to everybody. So just go and get yourself signed up. Stu will get you added to the Slack channel, and we'll look forward to continuing the conversation there. And if you've enjoyed today's webinar, our next webinar is actually going to be all around upgrading to 6 gigahertz Wi-Fi. We know this is a super hot topic, and sometimes you may not know what you should and shouldn't be doing when it comes to upgrading, especially when it comes to 6 gigahertz and all the different rules and regulations. And if what I can and can't do. So we're going to be covering all of that and more on our next webinar. So if you'd like to get signed up nice and early to save your seat, again, you can just head to ekahau.com/webinars, or you can scan the QR code and sign up there as well. So thank you so much, everybody. We're going to wrap up the webinar today, and we'll see you on that next one when we talk about covering upgrading to 6 gigahertz. So thank you very much, everybody. See you on the next one.
And good night from Dubai.